Imagine a world where the surface temperature could melt lead, where the atmospheric pressure would crush you instantly, and where the sky is perpetually shrouded in a thick, toxic haze. This is Venus, a planet of unimaginable extremes. Its scorching surface and dense, suffocating atmosphere present a stark, inhospitable reality. Venus is our closest planetary neighbor in the solar system, often visible as a brilliant beacon in our morning or evening sky. Named after the Roman goddess of beauty and love, its serene appearance from Earth belies its true nature. It is, without question, a planet of profound extremes. Despite its hellish conditions, Venus holds a striking resemblance to Earth in several fundamental ways. It is remarkably similar in size, mass, density, and overall composition. Both planets are believed to have formed around the same time, emerging from the same primordial cloud of gas and dust. They were built from the same cosmic building blocks, suggesting a shared origin. This profound similarity immediately piques our interest and raises a crucial question. Why did these two planetary siblings evolve so differently? What forces steered them onto such divergent paths? The early solar system was a chaotic and violent place, especially for the inner planets. They were subjected to an intense period of bombardment by asteroids and comets, a cosmic shooting gallery that lasted for millions of years. This tumultuous environment played a crucial role in shaping the nascent planets, delivering both destructive impacts and perhaps even vital ingredients. One of the most significant factors setting Earth apart from Venus is the presence of plate tectonics. On Earth, our dynamic crust is broken into massive plates that constantly move, collide, and subduct. This geological process regulates our planet's climate, drives volcanic activity, and recycles essential elements. Venus, however, appears to lack this global system of plate tectonics. Its surface seems to be a single rigid shell, preventing the continuous recycling of its crust. This absence leads to a buildup of internal heat and pressure, which is periodically released through massive, widespread volcanic eruptions that resurface large portions of the planet. Beyond its geology, Venus's atmosphere is perhaps its most defining and terrifying feature. It is incredibly thick and profoundly toxic, composed almost entirely of carbon dioxide, with clouds of sulfuric acid. This dense blanket of gas creates an incredibly strong greenhouse effect. The carbon dioxide traps heat with astonishing efficiency, preventing it from escaping back into space. This runaway greenhouse effect has driven surface temperatures to over 460 degrees Celsius, making Venus the hottest planet in our solar system, hotter even than Mercury, which is closer to the Sun. The atmospheric pressure at the surface is also crushing, more than 90 times that of Earth's sea level. The stark contrast between Earth and Venus leads to one of the most compelling mysteries in planetary science. What was Venus like in its past? Recent research based on sophisticated climate models and geological interpretations suggests a tantalizing possibility. Venus may not always have been the inferno we see today. There is growing evidence that Venus might have had plate tectonics in its distant past, perhaps even oceans of liquid water. If true, this would mean Venus once possessed a far more hospitable, even Earth-like, climate. Such a dramatic shift would represent one of the most profound planetary transformations imaginable. The central question then becomes, what caused this catastrophic change? What event or series of events triggered the runaway greenhouse effect and the cessation of plate tectonics? Understanding this transition is not merely an academic exercise. It has profound implications for the search for life beyond Earth. If a planet so similar to our own could undergo such a radical transformation, it forces us to reconsider the conditions necessary for habitability elsewhere in the universe. It highlights the delicate balance required for a planet to sustain life over geological timescales. The history of Venus remains shrouded in mystery, a testament to the complex and often unpredictable evolution of planets. Venus presents a complex and captivating story, filled with twists and turns that challenge our understanding of planetary evolution. It is a world of extremes, a stark reminder of what can happen when a planet's climate spirals out of control. Its present state is a powerful cautionary tale. Studying Venus provides invaluable insights, not just into our own solar system, but into the broader search for life beyond Earth. It helps us define the boundaries of habitability and understand the forces that shape planetary destinies. Venus reinforces the central themes of extreme environments and mysterious pasts, urging us to continue our exploration of this enigmatic world. Please subscribe and like to help our work. Thank you, and see you soon.